Hi, today we're talking about how to draw these three gears in OpenGL from scratch using C++. Let's first take a look at the shapes of this. You can see that they're essentially cylinders with different radius and also a little bit different radius on the edges. So that will be the design concept of how we make this model for the gears. And let's dive into the code. So we need two files and also some of the default or convenient libraries from OpenGL as well. You can check out my other video to see the setups for this file. And I'll just run through all the code and give you a general idea of what kind of components are needed. So first we construct a class of models where we need the number of vertices and indices just so that you can set up the numbers manually every time you call the function, and it's much easier to debug. And also the vertices and the indices themselves, and the VBOs for the vertices and the EBOs for the indices, and then we generate the buffers for the two of them. And the first function we need is a general function for our models. So after the generation of the buffers, we'll need to bind the buffers, essentially the vertices, which is the VBO, and put the number of vertices and the vertices itself there, and also the EBO, which is for the indices. And the size of them, don't forget to change the sizes because they're different. So for essentially for the vertices, so you have starting from the index 0, you go through three of them, so x, y, z. And also for the texture, you start from we name it the second index, which is index 1, and then it needs two of the we call the UV value. So in total there's gonna be 5 of them, so that's why it's 5 times the size of the float. And it's gonna start not from 0 like the vertices, but it's gonna start from the third it's actually the fourth of them. So you're gonna skip the first 3 of them. And next we need the model, view, and projection, which are for the rotations if you want the gears to be rotate, and then the translate to basically to put the vec3 onto a 4-dimensional matrix, and the perspective to sort of project the view from the camera onto the screen. And then we use the shader to put a model, view, and also projection onto their locations. And last but not least, GL drawer elements. If you use indices, it's essential to use this function so that you put all of the vertices, which are conveniently reduced by adding the indices. But if you only have vertices, then you just GL draw arrays with the number of vertices you have. And also, after creating the models, we need a deconstructor to delete all the pointers from the vertices and indices. So let's skip down to the gear part. As you can see, it's quite convenient where you can create several models once you get one this class established. So for the gears, we have the radius and the tooth of the radius, like the edges, and then the height of oh, essentially they are cylinders, so you can think about it as like the thickness of the gears, and also the size, how many sides you want it to be, because you all know it starts from polygons and it just grows. The more it gets, the more similar to circle it gets. These protruding sides are for like how many of the teeth sides you want. So because we'll need both sides for many times down in the loops to generate vertices, so we put it in one variable. And also the combined radius. At first, we initialized the vertices to be 5 times 2 because like we mentioned before, we have x, y, z, the coordinates for the vertices, and uv for textures, that's 5. And we also have top and base, so 5 times 2. And for the indices, so essentially we're drawing triangles for the sides. So for each triangle, we use 3 vertices, but for each side, we need 2 triangles. So 2 times 3, that gives us 6. For each one side, we'll need 6 of them. So 6 times the sides. So here we comes down to the loop of the real drawing of the vertices. So we make up the loop, and within the sides of the loop, for each side, the top is gonna be 5 times 2 times I, and the base is just gonna be top plus 5. So similar thing as we mentioned 5 there, x, y, z, and uv. And also we need the angle, and we need 2 pi times the sides. So we're not using degrees, but we're using cosine and sine values of them. So you can also refer to the definition of these two math functions. So essentially we need the x value, which is the cosine, and y value is the sine value from the radius. We've mentioned this in another video too, but essentially because if you draw a circle, and if you want to know any point on this circle, the cosine value would be the x value and the y would be the sine value of it. Yeah, and then we get the height, and for the textures, just equally distribute over the sides. And for the base, everything is the same except the height is gonna be the opposite because it's on the base. And consider here we're having if elseness, just so that when the eye is divisible by the protruding sides, which means, so if we have this polygon here, and we have the points where it's supposed to generate, if let's say the cylinder first, then if it's this kind of points, then our radius, the length would just be the length of this radius. But if you want the gears to have the teeth there, so you want the length to be longer than just this radius, so it's going to be a protruding length plus the length. So everything is the same, except that you replace the radius with the protruding radius because it's going to be a little bit longer. Yeah, and that's essentially all the code that you need to generate the vertices. And let's take a look at the indices, where like we mentioned before, it's going to be 6 times I. And the one thing you need to notice here is we use a two-stepper, you could call it, mostly because for each loop we're essentially trying to get to like the next side, because I is basically in the range of the sides. So in each side, we have two triangles, and for we can sort of think about the first one. So start from 0, and then we go down here 1, and remember on our vertices we keep going down because we get to the second loop, then we have the same height, so 2 is down here and 3 up here. And for the indices, if we want to connect, we connect 0, that's I, and I plus 1, and I plus 3. So we connect this 3 and we connect this 3 to form two triangles. But when we jump to the next loop, we don't want to repeat the second one again, but instead we want to jump to one more step, two step, the second step after this one. So that's why we put a stepper of 2 here, so that when it comes to a next loop, it's gonna jump to twice of it instead of repeating the second triangle in the same side. We want to jump to the next side. So, and also just the edge cases where when it goes to like the last one before the final side, just reset it to 0 so it won't go out of the bounds. Yeah, and this is the models we've generated, and let's see how we implement this to the final file for the gears. So first we want to get the cameras so that you can sort of see the views using the keyboard to control it. So you put essentially change the values here in the vec3 so that it can go zoom in, zoom out. We're gonna show this a little bit later. And also we need the yaw, pitch, and field of view for the mouse movement, which is essentially where your cursor is. And the way to do is to make the different positions for each frame. So to create the mouse movement with the views change. And then we use the key WSAD, or you can name anyone you like, to make the movements we mentioned up there, and also the mouse where you can change some settings, especially I guess mostly the sensitivity about the mouse, and also just to make sure it's kept or like within the bounds. Similar thing with the zoom in and zoom out, it should be within the bounds. So here comes to the part where we generate the gear object. So for this one we have 3 gears, so we set up gear 0, 1, 2 with different radius, and we wanted to put them into an array of objects because we're not creating just one. So we put in different radius and to push them onto the array. And then of course delete the objects after we're done. So down to the main function, initialize the windows, the mouse movements, and enable depth test. Remember, if you are in 3D, it's really important to get the depth test, and also get our shader files in there, and then call our create object function. And then remember before we had already generated the VBO and EBOs from our model file, and here we need also the VAOs And also the texture. If you have two textures, then you can mix them in your shader files and just put your file picture texture picture file in there from the first one, and then generate the second one. And we clear the window and start to draw, and then we get the shader, we get the look at function to render our view. And the most important thing here is the drawing function. So in our array of objects, we start from the first one, index 0, 1, 2, and you put in the different actually you don't have to put these numbers as long as they're separated with the distance that you want. So just put the x, y, z values for the positions to draw each of them on, and then we just read the events from the event queue and then delete all the buffers that's there. So that's about it, and you will luckily you will get this kind of gears. And also you can see I can use the my mouse to kind of maneuver the view, and sorry, that's the keyboard, and this is the mouse movement. And you can of course change the settings, and I hope this is helpful, and I'll link the source code in GitHub in the description below. And thanks for watching.